Hi, this is my video of my new Harbor Freight 14-inch wood cutting bandsaw that I converted recently. It looks very similar to every other Harbor Freight 14-inch vertical bandsaw, but there's a slight difference on mine. You see that? There's a dial I added right here, and that's a rheostat that controls a DC motor controller. Here's the power switch that comes with it. That comes with the bandsaw, and go around this side. I can turn it because I put casters under it. So here is a KBIC 240D motor controller that I put in a plastic box to keep the shavings out of it. And then right here we have hopefully you can see that it says Hallmark Industries 90 volt, 1 horsepower, 1750 RPM, 10.4 amp, NEMA 56C frame motor. Okay, I'll pull back a little bit. It just barely fits inside there with about an 1/8 to 1/4 inch on the back side, and I put a, if you can see that, I put a 2-inch pulley on this side. Okay, now you can see that I also have added the link type belt to it. It's a V-groove belt, but you can change the length, and it also reduces vibration. Okay, pull them back out here. There's no real difference to the saw itself other than I added this roller guide to it. I bought that off of eBay, and it was like, I want to say $40. The KBIC 240D motor controller was about $80, including shipping and the resistor that's required to set the horsepower resistor. Okay, so that's all great. It's on a Portamate PM1000 caster system. It's kind of like a movable base, and I'll turn it on and let you hear. This is the power switch. Up is on. Here's the rheostat that controls the speed. There's a very low RPM. Kind of dark in here, sorry about that. And you can see as I turn it, hear the motor speed increase. So why did I do all this? I'll turn it back off so you can hear me talk. So I did all this so I could cut sheet aluminum and maybe some mild steel. I have a metal cutting blade on here right now, 14 teeth per inch bimetal. I think it's a 3/8 inch blade, and so far I cut some aluminum with it and it cut just fine. The problem with the way it was added from the factory is it comes with a alternating current motor instead of the DC current motor, and so changing the speed means you got to move these pulleys around, and the lowest speed really isn't slow enough to cut metal with. So I went with a 1 horsepower variable speed DC motor. It's a permanent magnet motor with, just a standard motor. And come around this side, I'll turn it. It's got wheels on it. I can be able to turn it real easy. So we can have the light. Okay. So here's inside. I had to make a slight cutout right here in the corner because it was real close right there. So I just took a metal rotary file and opened that up a little bit. And you can see here's the V-groove. Here's the link type belt. You get these at Harbor Freight for 28 bucks. Everybody else, no, let's see. I think it was 24 bucks. Everybody else charges about 30 bucks for that same exact belt. So go buy it at Harbor Freight with a coupon and save a few bucks. Here's a step from the original configuration. This is a step pulley, and this is where you'd normally change the speeds, but it's not necessary anymore because of the DC motor. And this shaft lets you move this upper V-groove pulley in and out. There's a I'll turn this around. is a set screw right there. So you can move this in and out, and the way you adjust this in and out is there's a nut, and there's a nut on the opposite side that allows you to move it in and out. So I did have to drill a few holes to make the motor fit, and I really can't put instructions up because I kind of did it on the fly and didn't videotape it. But the main thing is you got to get that motor as close to the back wall here as you can. Mine's about 1/4 of an inch away from the back wall, and the front just barely has actually it has quite a bit of space, but you need to be able to line that bottom pulley up with the idler pulley up in here. Let me see if I can get a better shot of that. See, here's the idler pulley. You have to be able to line this. You have to be able to line this V-groove pulley up with the one down here. So keep that in mind, and you're able to move the V-groove pulley in and out on the shaft. You know, it's got a set screw on it, and it comes with the keyway. So it all fits together real nice. I'll try to put some links in the description that explain where I got all the parts. Most of the parts came with the machine, like this power switch, and then I added, of course, the motor and the motor controller and wired it all up. It works off of 90 volts, so it takes your 110 volt household current, converts it to 90 volts, and then sends that out as DC current to the motor, and then it basically switches on and off like hundreds of times a second to control the speed. So it's like a switch that opens and closes. There's like SCRs in there. They're kind of like solid state relays, and they open and close to allow you to adjust the speed of the motor. It's called pulse width modulation. If you want to learn more about that, you can look that up on the internet. Anyway, here it goes again. Turn it on. Turn the rheostat. There we go. It's got a bit of a vibration going on. I gotta figure that out. Anyway. Turn it up full speed. So what'll happen is if I find out this speed is just way too low for me, I just would have to get a bigger pulley down here, and that would increase the top speed. Okay, that's all I got for today. I'll just pull out, show you an overview of it, and that's it. Did this on my iPhone, so sorry about the video.